Hi, I'm Saad, and my research is on Alzheimer's, specifically the BACE1 protein. Now, my job was to design a allosteric inhibitor to inhibit the protein from reacting to the APP, amyloid precursor protein. Now to really understand my research, we first have to look at something called the amyloid hypothesis. So basically, in a healthy brain, proteins are recycled normally, but in Alzheimer's, an enzyme called BACE1 acts like essentially molecular scissors, cutting these proteins into sticky fragments that clump together to form toxic amyloid plaques. Now, these plaques are the primary drivers for neurodegeneration. For decades, scientists tried to plug these scissors directly, but those drugs failed because they were too blunt, essentially, shutting down the enzyme entirely and causing severe side effects. Now, my project changes that approach. Instead of trying to break the scissors, I want to retune them, essentially. I developed a custom 15,000 line particle swarm optimization algorithm to engineer a novel allosteric drug candidate. Now, this algorithm performed essentially a search to find a ligand in just 22 days. Ligand is just another way of it to say drug, essentially. And the PSO designed a ligand that binds to an allosteric pocket, changing the enzyme shape so it can no longer produce these toxic plaques. Now, to prove this worked, I ran a 120-second molecular dynamics simulation. I discovered that the protein was essentially locked, especially its catalytic dyad residues, the residues which are used when it reacts with APP, the amyloid precursor protein, to produce those sticky fragments. Now, this enzyme stabilized the cutting mechanism at around 0.076 nanometers, effectively freezing it in an inactive state. Now, my data showed a 44% reduction in atomic wiggle, confirming that the enzyme was physically locked. Furthermore, Swiss ADME analysis verified that this molecule is small and stable enough to cross the blood-brain barrier, making it a viable candidate for oral pill. Now, for the conclusion, I concluded that PSO-driven design allows us to create safer, precision-targeted medicines faster than ever before. By moving from reactive plaque removal to proactive prevention, we can finally address the root cause of Alzheimer's without collateral damage of previous therapies. Thank you for your time.